Welcome to another video. Let's solve this algebra problem of x raised to power 6 minus x raised to power 3 equals to 2. Uh, we just want to find all the satisfied value of x in this. And to start with, if you have x raised to power of 6 minus x raised to power of 3 and negative 2 equals to 0. But this x raised to power 6 can be written as x raised to power of 3 all raised to power of 2 minus x raised to power of 3 minus 2 equals to 0. So I want to do something different. So I can let x raised to power of 3 to be any alphabet, but I don't want to do that. So what I want to do is to apply the quadratic formula. Uh, if you have, let's say I call this one a raised to power of a raised to power of 2 minus, if this is a and here is minus c equals to 0. Okay, so if this x raised to power 3 is our a, and if you borrow the knowledge of quadratic, instead of having just ordinary x, we are going to have x raised to power of 3 instead. Then we have from this quadratic formula x equals to minus b plus or minus the root of b square minus 4ac, everything divided by 2a. Then we know x is now our x raised to power 3, and if you plug in it here, so we have the coefficient of x raised to power 3 to be 1, and this x raised to power 3, the second one, to be negative 1, and the constant is negative 2. So we have x raised to power 3 equals to, we are going to have minus 1 as the value of b, plus or minus the root of b is negative 1 but all raised to power 2, minus 4 dot a is still 1 dot y still is negative 2, and we bracket this, everything divided by 2. Then we have x raised to power 3 equals to 1 plus or minus root of 1 plus everything here is 8 divided by 2. And we are going to have x raised to power 3 equals to, we have 1 plus or minus, a is going to be 3 if you take the root of this, so let's say 9 first, divided by 2, and we have this as 1 plus or minus 3 divided by 2, and by separating this with plus or minus, we have x raised to power 3 equals to, here is 2, or so we have x raised to power of 3 equals to negative 1. Here is the first stage. Let's see how to find all the 6 roots. So let's deal with this one first. If we transfer this, we have x raised to power 3 minus 2 equals to 0. So how can we go with this value of x? And y for this one is x raised to power 3 plus 1 equals to 0. So to do that, if you consider this identity as, if you have a raised to power 3 minus b raised to power 3, everything equals to, we have a minus b bracket a square plus ab plus b square. While for the sum of 2 cube, we have a raised to power 3 plus b raised to power 3 equal to, here is a plus b bracket a square minus ab plus b square. So we're going to use the first identity to deal with the first one, then later the second one. If you have x raised to power 3 minus, but these two If I have it as cube root of 2 all raised to power of 3, so it's still the same thing as 2. So we have all equals to 0. And by applying this, we are going to have x raised to power 3 minus the cube root of 2 all raised to power of 3 equals to, we know our a is x and b is cube root of 2. So we have x minus cube root of 2, we bracket this, bracket, the second one is x raised to power 2 plus, we have a and b, so and everything turns to the cube root of 2x plus, why this last one is cube root of 2 all raised to power of 2, and bracket everything. So but since everything here is equivalent to 0, so we are going to have either x minus the cube root of 2 equal to 0, or we have s raised to power of 3, s raised to power 2 rather, plus the cube root of 2x plus the cube root of 2, everything raised to power 2 equal to 0. So it is clearly that the first root, which is s1, equals to the root cube root of 2. So here is the first solution. Why for this one, we can solve this one using quadratic formula, or we can still use completing the square method. So why, if you have this as a equals to 1, b equals to the cube root of 2, and c equals to the cube root of 2 all raised to power of 2. And by applying the quadratic formula here, we have x equals to minus cube root of 2 plus or minus the square root of, so we know the b is still cube root of 2, so we take the square of it, we have cube root of 2 all raised to power 2 minus, so we have minus 4 dot a is still 1, we have c, which is the cube root of 2 all raised to power of 2, and we divide everything by 2. Then since from this we have what is common to both, which is 2 raised to power of 2 over 3 is common, then we have x equals to minus cube root of 2 plus or minus, if you take it out, we have square root of 2 raised to power of 2 over 3, we take it out, then we create a bracket, another root, so here becomes 1 minus 4, all right, and we divide everything by 2. Then we have x equals to negative cube root of 2 plus or minus, we have the square root of, so in everything here we have square root of 2 raised to power of 2 over 3, bracket, we subtract 1 and 4, we have minus 3, and everything divided by 2. So what to do here is a complex root, and it is given as the root of 3i, and by replacing it, we are going to have x equals to negative cube root of 2 plus or minus, we have a square root of 2 raised to power of 2 over 3, bracket, the root of 3i, and everything divided by 2. But we must know that this value, which is x2 and x3, does not satisfy the equations. All right, so the complex root here, which we just got as x2 and x3, does not satisfy the equation, but the first one, which is the cube root of 2, satisfy the equation. You can check for that. So let's see how to obtain the other roots. But if you check what we have from the above, which is x raised to power 3 plus 1 equals to 0, and we use the sum of two cube to do that. So whereby we have the question is x raised to power 3 plus 1 equal to 0, and the identity state, if you have a raised to power of 3 plus b raised to power of 3 equal to a plus b bracket a raised to power 2 minus ab plus b square. So let's start plugging all this. X raised to power 3 plus 1 raised to power 3 is still 1 equals to our a here is x plus b is 1 bracket open bracket. We have x raised to power of 2 minus here is x and plus 1, and everything is still equals to 0. So we have gotten the value of x, and let's see how to do this. X equals to x plus 1 equals to 0, right? Or we have x raised to power 2 minus x plus 1 equal to 0. Then we have x equals to -1, which is x4, and also satisfy the equation. You can check for that. And while for this, we have we are going to use completing the square method for this instead. I know the quotient of this x is -1, and if you divide it by 2 and square it, so which means we add and subtract these two. By adding and subtracting, we are going to have x raised to power 2 plus 1 divided by 4. All right, so I can let 1 divided by 4 first, and I subtract x from it. So if you bracket this, you know we have added 1 over 4, then we still subtract 1 divided by 4, and we add 1. Everything equals to 0. So if you try to compress this, all right, we are going to have x minus 1 divided by 2, all raised to power of 2. So try to expand this, you get above. And y for everything here becomes plus 3 divided by 4. And if you have 3 divided by 4 here, we are going to have x minus 1 over 2 all raised to power 2 equals to minus 3 divided by 4. Then if you take the square root of both sides, we are going to have this is plus or minus, and these two cancel. X minus 1 divided by 2 equal to plus or minus. By separating this, we have minus 3 divided by 2, because 4 is a perfect square. S equals to 1 divided by 2 plus or minus. Why this is still remain root of 3i, everything divided by 2. And we can conclude that x equals to 1 plus or minus the root of 3i all divided by 2. Why this is x5 and x6, and which this one does not satisfy the equation as well. It is only x equals to -1 and x equals to cube root of 2 that satisfy the equation, and this is how to do it. I hope you learned something today. Thanks for watching, and don't forget the steps I use. Subscribe to this channel, and I will see you in the next class. Never stop learning. So hereby we have 2 real roots and we have 4 complex roots, but all these 4 complex roots does not satisfy the equation. Thanks for watching again. Give a thumb up. Bye bye.